Hello. So we're going to see if we can fix this Cuisinart CSO300, which has uh, been beeping anytime you try to start a steam function. It beeps and says add water. So we've checked it out, and so the reservoir, which is this guy down here. Hold on 1 second. So the reservoir. So we're helping a friend with this, and they actually have not done the maintenance, which is to decalcify it every. I guess it's once or twice a year. You put vinegar in and run it through the system. So there's probably calcium buildup in it. So we took the side off. We tried to do the what the manufacturer recommended, which was to add a vinegar mix half and half to this, let it run through the system 30 seconds, and it would clear itself, but that did not work. So there's something more significant going on. It still could be calcium, I think. So this is what the innards look like. This was on here to there. That's kind of the connection between the upper reservoir and the internal reservoir. And I was able to get water with vinegar mix down into here. I actually heated it up and put boiling water with vinegar in there. You can see a lot of deterioration here. I didn't check to see whether or not I got 120 volts there, because I don't think that that's the issue. There is online discussion about a probe that tests the water level, and I have not figured out where that probe is. So we're gradually taking it apart, and it's taking me a little bit of time to figure out how to take it apart. These little caps are in here which cover up the screws, so these caps need to be pulled off with a small pointed object like this, and they pop up. I'm going to take this off and see if we can access the internal reservoir here, and see if we can identify the probe and if it's caked with limestone or not. Okay, so we've got the black cover off, which is where the reservoir usually sits. Here's the internal reservoir. Also undone the 4 screws down there. So this is now loose. I'm going to take this guy off, and we're going to take this reservoir out, open it up. I think we can just open it up and check out what's going on inside with the probe. Okay, so we've taken out the screws, and here we have the insides. This I think that's a ceramic heating element, if I understand what's going on here. Caked up, but I don't actually see a probe. So when people talk about a probe, I'm not quite sure what they mean. There was in this if you can see it there, but it's like a red ball. I don't think that's a probe, so I'm not quite sure where to go from here. I'm going to pause and think about it. I did not disconnect the wiring down here. It was actually a little hard to take off, and as far as I could tell, even though there's a bunch of corrosion up here, it didn't really feel like there was there's a loss of contact. So maybe I should have checked that. I might still check that and see if I can get 120 volts in continuity. I guess I could just check continuity across the terminals. Maybe I'll do that next. Okay, so now I'm feeling a little stuck. Here's the reservoir, and you saw from the picture I just showed you that there's no probe in there. Now look at the bottom. I can see the 2 terminals, the hot and neutral terminal. So that's what causes it to heat up. And then there's this guy, which, if I could show this white line, and then over here this other white line, which to me would say a probe. And it's a little hard to decide. I mean, the contacts are not corroded on either of them, so I'm going to test it with conductivity and see if I've got conductivity on both what I'm calling the probe, but I'm not totally sure is a probe, and the power. Okay, so this is interesting. You can see. So this is interesting. So here you can see my multimeter, and I've got connectivity there. If you can hear that, it's a little hard to hear perhaps, but yeah, I've got conductivity, and then in here, when I put it on either side of this probe, I get nothing. If I put it on the same side, there I've got connectivity. So I guess the probe is bad. Now how I fix that, because I don't quite figure out. So it's connectivity in those terminals. And there's connectivity on the power. So if I go in here, I can get to these two power. There's power there, and so it's just this probe, which would make sense. So it doesn't think it's getting water even when it's all full up. So ideally, I could just buy a new tank, new assembly. I'm not sure if I can. Okay, so we've now taken the wire in out, taken these off, and I'm gonna see if I can just clean off the terminals, and maybe that'll fix everything adequately. So this is interesting. So I couldn't get the lower screw off, and I started to strip it, so I stopped. So I just decided to rotate this. This is what I think is the probe that senses water in the container, and there is a lot of deposit that has built up. If I look on the other side of it, you can see I wiped a little off already. So I'm going to clean that, and that might do it if I don't break it. Actually, I'm going to be careful here because I'm bending it back. So maybe that'll fix it. So as a result of COVID, there are no parts for this Cuisinart. I searched eBay and I didn't find any either, but I'm happy to see that here's a little bit of information on this sensor. So maybe I can find that if this doesn't work. But I've cleaned it up at least a bit. I'm going to maybe try to clean it up a little bit more and then reattach it, put everything back together, or at least test conductivity. One mistake I made earlier is that when I was testing these terminals, I didn't test with water in here. And I assume that has something to do with the maybe once it heats up. I'm not quite sure actually how it works. So I might test it with water and maybe with boiling water and see if it registers conductivity over, is that 125 degrees C? Well, boiling water would be at 100. So yeah, I'm not quite sure, but hopefully this helps somebody. Okay, well, here we are again. So as I mentioned before, we did a test across the thermal switch. Actually, this is the old one right here, and we didn't get a normally closed reading, meaning that we didn't get continuity across the two metal strips here for this guy. So that indicated that this one was broken, and I looked on the back and it said 125C, T18, 15 amp, 125 volt. So my friend who knows about these things said that the 18 he thinks is the diameter of this internal ring, and he was right. So it's 18, and it was 25 millimeters here, and 125 volt, 125C. Sorry, 120 volt, 125C, and 15 amp. So I struggled for a while. Looked on Amazon trying to find exactly that. Couldn't find it. Found a whole bunch that were 250 volt, 10 amp, 125C, and he reminded me that what matters is first and foremost is that 125C cutoff, because that's the safety, and the power across this. And he said that roughly 250 volt and 10 amp, right? That's the you could argue that it's like the strength of the connection here to withstand the voltage drop. So actually there was a difference between these when I got them in, and you can see that here, which is that the 120 volt had a slightly narrower, I think it was a 4 millimeter connection, and this guy had a 6 millimeter connection. But they both should work, and I tested the new one, and it goes, and then it basically ground down. Somebody will tell me that this is not the right way to do it, but I ground this down to 4 millimeters on each side, and everything else worked perfectly. When I installed it, it kind of rotates around like this. So I installed it, and I got 4 of these for, I think, $10. It would have been great to get one for $2, but now I've got extras. If anybody wants them, I'm happy to send them to you. And I've put it all back together, and we are going to test it in just a moment or two once I get it all back together. Okay, well, here we go. We've got the Cuisinart going again, and it does not say add water, so that looks like that fixing that thermofuser, which had gone out, did the trick. And I went on steam, and let's see if we got some steam coming out of here. We'll see here. This yes, indeed, I see steam. It smells like vinegar, because I think we had some vinegar in there from the decalcification. That is I guess a $2 part that fixed a $350 machine, and cost me a few hours of time, but it was fun.